All right, welcome back. In this video now, we are going to talk about some molecules or some structural analog, some drug, some compound that inhibit pyrimidine biosynthesis. Remember during the purine, I already told you guys about some things that actually inhibit purine, okay? And one of them was methotrexate. Now we're also going to see the methotrexate again here. You can see methotrexate here, okay? We're going to see the methotrexate again. Then this time around, we're seeing this new one, 5-fluorouracil. 5-fluorouracil, okay? All right, so this entire thing we're trying to talk here about is the inhibitors of pyrimidine biosynthesis. Do you understand? Sorry. The inhibitors of what? Pyrimidine biosynthesis. Inhibitors. Now, there are two I have outlined here, methotrexate and what? 5-fluorouracil. Now, you will remember during the biosynthesis of pyrimidine that the time comes whereby we convert the deoxyuridine monophosphate, in short, dump. We convert this deoxyuridine monophosphate to what? To deoxythymine monophosphate. I don't know if I have that part here. Let me check. Okay, I think not so. Remember this part whereby I converted, you can see it here now, this dump to deoxythymine monophosphate, okay? Remember we said folate is being used here. So this is the full reaction. Are you seeing it here? Dump to deoxythymine monophosphate. The enzyme is called thymidylate synthetase. And this enzyme basically makes use of this as a cofactor. So this is the molecule that gives us the methyl group. So N5, N10 methylene tetrahydrofolate. It will enter the pathway and it's going to come out as what? As dihydrofolate. So basically we use N5, N10 methylene tetrahydrofolate. It reacts with this reaction. It gives us our methyl group, and at the end of the day, it changes to it in dihydrofolate. Then we are going to convert this our dihydrofolate again to tetrahydrofolate. So we'll make use of this reducing equivalent here to reduce it to tetrahydrofolate. Tetrahydrofolate can also be converted again to this one through a separate reaction with the help of serine. Okay, so you don't need to know all those many details. The main thing I want to stress here is that this reaction is inhibited by what? It's inhibited by what? 5-fluorouracil. It's inhibited by 5-fluorouracil. Okay, it's inhibited by 5-fluorouracil. Then again, come to this side. This enzyme here that basically help us to reduce our dihydrofolate. This is dihydrofolate, right? We convert dihydrofolate to what? To tetrahydrofolate. Is that not so? Dihydrofolate to tetrahydrofolate, so that we can form this one again and we can do the reaction again. I get my point. Remember when we converted this to this, we make use of this methylene tetrahydrofolate. We now form dihydrofolate. You will still need to go and form it again so that for other ones that are coming, you can still convert it. In order to reduce your dihydrofolate to tetrahydrofolate, you make use of this enzyme called dihydrofolate reductase. What do I say? Dihydrofolate reductase. Dihydrofolate reductase. This enzyme now is being inhibited by this structural analog, which we call methotrexate. So this methotrexate has the ability to inhibit what? Dihydrofolate. It has the ability to inhibit dihydrofolate. When you inhibit this one, you cannot do pyrimidine biosynthesis. I get my point. So if you cannot do pyrimidine biosynthesis, you cannot synthesize thiamine. If you cannot synthesize thiamine, you cannot synthesize DNA. I get my point. So all those cells that require DNA for like constant replication like your cancer cells, we can use methotrexate. So all this methotrexate, they are what? Anti-cancer drug. Because why? They inhibit nucleotide synthesis. If they inhibit nucleotide synthesis, it means they will inhibit DNA synthesis. Then from there, they also inhibit DNA replication. Do you understand it? So let's go over this thing again. This is deoxyuridine monophosphate converted to deoxythymidine monophosphate using thymidylate enzyme. I said 5-fluorouracil inhibit this enzyme. Also, we said that this enzyme make use of what? N5-N10 methylene tetrahydrofolate and convert it to waiting to dihydrofolate. Then also, then this dihydrofolate will need to be converted again to this. In an attempt to convert dihydrofolate to tetrahydrofolate, which will then be converted to N5-N10 methylene tetrahydrofolate, we make use of what? We make use of what? A particular enzyme that is called dihydrofolate reductase. Dihydrofolate reductase. This enzyme can be inhibited by what? Methotrexate. So I said drugs like methotrexate and 5-fluorouracil can be used as what? As anti-cancer drug. Anti-cancer drug. Because why? They're capable of inhibiting nucleotide synthesis, and nucleotides are required for DNA replication. Do you understand? So if a cell that is replicating constantly does not have enough nucleotide, that cell will be inhibited. So that's why those cells like cancer cells, these things are not acting as anti-cancer drug. All right, thank you. We'll see in the next video with some diseases.